Okay, so today we're going to talk about some different types of ways that we can prove that triangles are going to be congruent. So we've talked about how triangles have 6 corresponding parts. Okay, they have 3 sides and 3 angles. But somebody came along and they proved that there are different ways that we can find a few 3 to 2 correlations between 2 triangles that allow us to say, well, they are actually congruent, and I don't need to prove that all 6 are. See, if I prove that this, and this is congruent, then that means the rest of it is congruent. So I don't need to really worry about trying to figure out all 6. Instead, I can do 3 or 2, okay? So we're going to talk about that, and if you look here, I have the different ones here. We have SSS, SAS, AAS, ASA, and HL. Okay, unfortunately, there is no angle side-side, okay, which is ASS, so you're lucky for that, right? So we don't have that, so that won't be one of our congruence theorems. Okay, so let's just start with SSS, which is side, side, side. So in order for 2 triangles to be congruent, if I prove that their sides are congruent, then that means that means that the whole triangle is congruent to the other triangle. I don't have to prove that their angles are. If I prove that the 3 sides are, then that means that their angles have to be congruent, okay? So this goes back to that similarity idea, okay? If I prove that 3 sides are congruent, then that means that the 2 triangles are congruent, okay? We also have side, angle, side, okay? Now, the reason why the angle is located between the 2 sides is because it's called included. It's an included angle. So included angles mean that they're between the 2 sides that are congruent. Let me show you. If I have a triangle and I show that these 2 sides are going to be congruent to another triangle's 2 sides, the included angle is between the 2 sides. So it cannot be here and it cannot be here. It has to be here because it's included. It's between the 2 sides. If I show this property, then that means that these 2 triangles are congruent. And that means that all the parts that go with it are congruent. The other side and the other angles. Okay? Okay, so let's take a look at the other ones then that I was talking about in the beginning. Let's take a look at the other types of congruence theorems that we have. We also have the angle, side, angle. This time, the side is an included side. That means that it's between the 2 angles that are congruent. To show you that, if I show you 2 triangles, this is congruent to this is congruent to this, that means the side that has to be congruent has to be in between those 2, okay? It cannot be out here, it cannot be out here, okay? It has to be here and here. Now, if I show that those 2 sides are congruent, and I show that the angles are congruent there, then that means that these 2 triangles are congruent. And since they're congruent, that means all their parts are also going to be congruent. So I don't have to prove all 6 parts. I only have to prove 3. Okay, we have one more 3-letter theorem, and that is angle, angle, side. Now this one's a little difficult to recognize. There is no included angles or sides in this one, but you have to have 2 angles. If you look, angle, side, angle, up top, the side is included. For this one, the side is not included. It's excluded. So what I want to show you then is an example of 2 triangles that could be angle, angle, side. So the first thing you have to have is you have to have 2 angles that are congruent. Now, the side has to be excluded. That means it cannot be between the 2 angles. So for example, it could be this, but if it's going to be that one, it has to be this one, okay? It cannot be this one. If it was this one, then the 2 triangles wouldn't be congruent, okay? So it matters on the placement of that side. That side has to be the same excluded side. So that's how that's going to work. So if it does follow angle, angle, side, then that means that all the triangles, those 2 triangles are going to be congruent. Therefore, all the parts of those 2 triangles are also going to be congruent. Okay, so just make sure that you understand that. Okay, we have one more triangle congruence theorem, which is called HL. HL is a triangle congruence theorem that will only work with right triangles. So I have to have a right triangle in order for me to be able to do HL. So HL, only right triangles. So let's take a look at two right triangles. Okay, you may know what HL means. HL means hypotenuse leg. Okay, so hypotenuse, which is across from the right angle, is congruent to the other one. And one of the legs is congruent. It doesn't matter which one. Okay, you just got to make sure that one of them is congruent. So this one has to be congruent to that one. Okay, and that follows HL as long as it is a right triangle. All right, so let's do an example. We're going to use the side-side-side postulate to explain why triangle ABC is congruent to triangle DBC. If you look right now, we have two sides that are congruent. We need a third one. But if you notice, they share a side. They share side BC. So that means if they share one, that means it's got to be congruent to itself, which is the reflexive property, right? So what I would say is through the reflexive property, BC is congruent to BC. Therefore, the triangles are congruent. So triangle ABC is congruent to triangle DBC through side, side, side. Okay? So because BC is congruent to itself through the reflexive property, that means that BC has to be congruent to BC, and therefore ABC is congruent to DBC through that side, side, side. Okay, so we're going to do the same thing. We're trying to see if they share anything, okay, the two triangles. And you should notice that they do share this side AC. So again, you're going to say that AC is congruent to itself through that reflexive, right? And due to that, we can say that the triangle is congruent to the other triangle. Why? Well, because of side, side, side. Okay, let's look at the diagram that's here. We want to use side, angle, side to explain why the triangles are congruent. Now remember, the angle is in between the two sides. That means it has to be included. So that means that when I go over to this shape, we should notice that this angle has to be congruent to that angle. So that's the only way that it would follow side, angle, side. Now, why is that angle congruent to that angle? If you said vertical angles, then you're right. Because, see, vertical angles are across from one another. And so what you would say is you would say angle X, Z, Y is congruent to angle V, Z, W. You may say, well, why do you have three letters, Hostetler? Well, it's because I can't just say Z, because Z refers to everything that's there. This angle, that angle, this angle, that angle. And I can't say and in a different order here because X corresponds with V. So it has to be in the right order because order matters when you're talking about angles. And why are these angles congruent? Well, these angles are congruent because they're vertical, right? And that's what you would say. Okay, well, angles are congruent because they're vertical. Therefore, these two triangles are congruent through side, angle, side. It's a real informal proof, okay? You're just explaining why it works. So again, we're going to use side, angle, side to explain why this one works. If you look clearly, BC is shared. So that means it has to be congruent through the reflexive property. So that means you have side, angle, side, and side, angle, side. So since you have side, angle, side, it works. Okay? And the reason is because BC is congruent to BC through the reflexive property. Therefore, the triangle is congruent to the triangle through side, angle, side. Because I have a side, an angle, and a side. I have a side, angle, and a side. All right, so what we're going to do is we're going to show real quick that these two triangles are congruent if x is equal to 5. So what you would do is you'd plug 5 in for x is, and you want to show that all of these sides are the same. So this is 5, this is 7, and this is 6. Once you've shown that, then you would say, okay, well, it's congruent through side, 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 because all the sides are congruent to one another. So real easy again, you're plugging it in, checking to see if it follows one of the properties that we've talked about. Okay, let's determine if we can prove this triangle, these two triangles are congruent through angle, side, angle. Now remember, recall, side has to be included, okay? It has to be between the two angles that are congruent. Okay, do you notice any sides that are shared? Well, you should notice that the one come down through the center is shared. So that means this is shared, so it has to be congruent. Do I know if any of these other ones are congruent? The answer is no, I don't. So what I do know is that I have an angle, and a side. You may say, Hostler, why isn't it angle, side, angle? Well, if this side was congruent to this side, then it would be angle, side, angle. But it's not angle, side, angle because the side is excluded. It's not included. It's not between the two angles. So no, I cannot. Okay? So why can't I do this? Because it actually follows angle, angle, side. That's why. Okay? So it's not through angle, side, angle. Okay, so we're going to determine whether or not we can use angle, side, angle again to prove that these two triangles are congruent. So NKL, this triangle right here, and the other one, LM and N. Okay, so in order to try to see if that's congruent to the other one, you first want to see if they share anything. Do they share anything? Okay, the answer is yes, they share this side. Okay, well, do I know that if any other angles are congruent or any sides or anything like that? Well, right now I only know that there are parallel lines or segments. When I see parallel, pay attention. When I see parallel, you should be thinking transversals. You should be thinking alternate interior angles, alternate exterior angles. Where are they? Are they located there? Okay, you should know then that this angle right here is congruent to this angle right here. Why? Well, because LN refers to a transversal that is cutting KL and NM. And it's parallel, so that means that these alternate interior angles are congruent. Okay? So right now, all I know is I have a side and an angle. Okay? I want to know if I have another side that's congruent. And the answer is I don't know if any of these other sides are congruent right now. Okay? All I know is that the side in between here is congruent. I wasn't given any side marks on here. All I was given was these lines are parallel. So right now I only have an angle and a side. So no. Okay, I cannot prove this through angle, side, angle because I don't know any other sides are congruent or any other angles are either. You may say, well, wait, Hosteller, isn't this congruent to this? The answer is no, it's not. Okay, I don't know if these two lines are parallel, so I cannot show that this angle is congruent to this angle. So this is no. Okay, we're going to do two problems with the hypotenuse leg congruence theorem. Okay, we're going to see if we can prove that these two triangles are congruent. Okay, so looking at A, we want to check and see if we have these two triangles here. We should know that this is a right angle because of the linear pair theorem. When we look at these two, are they going to be congruent? Are they going to be congruent through hypotenuse leg? Well, what we do know is we know that the hypotenuse, both of those, the hypotenuses, they are congruent, right? So since they're congruent, we need to now show that there's a leg that's congruent. Well, I do see one leg that is congruent, and it's because it's shared. So this does follow HL because there's a shared leg. Okay, now we have two triangles, and we want to check and see if those guys are congruent. Is this congruent to this through HL? Well, right now I know that a leg is congruent to another leg, but do I know that the hypotenuse is congruent? Do I know that this is congruent to this? The answer is no. I don't know that those are congruent. Why? I don't have any information that tells me they are. Okay, I don't have anything. I mean, they may look like they are, but we don't know. I mean, we don't have enough info to say that. So the answer is no, because the hypotenuse is not congruent. Okay. Okay, we got one more problem. So we're going to determine again if this works for HL. Okay. So what do I know? Well, I know that I have two right triangles. The right triangles, right now, the hypotenuse, those both things are congruent, right? We want to see if there's a leg then that's congruent. How do I know that's a hypotenuse? Well, that's because it's across from the right angle. So do they share a leg? And they do. Okay, they do share a leg, which is CB. Since they share CB, we can prove that these two triangles are congruent through HL. Okay, so that's it for today. What you need to remember is that in order for two triangles to be congruent, all their parts have to be congruent, their corresponding parts, which there are 6 of them, right? There are 3 angles and 3 sides. But there was somebody who came along and they proved that these little theorems will prove that all the parts are congruent. The side theorem, where all 3 sides are congruent. The side angle side theorem, where there's an angle that's included in between the 2 sides. That works. The angle side angle, where there's a side included. The angle side, where there's a side excluded. And then the HL, which only works for right triangles. So my question is, well, why doesn't like angle work? Okay, well, why wouldn't that work? I mean, why doesn't angle side work? And the reason is because that doesn't mean that the triangles are congruent. I mean, that's not enough information to tell me that they are. And you know, the angle one is real simple to understand. It's because things can have the same angle measurements, triangles and everything, but they don't have to have the same side measurements. Is every equilateral triangle, are they all the same size? No, just the sides are, right? I can have a 3-3-3 side right triangle or equilateral triangle, and I can have a 4-4 equilateral triangle, 4-4-4. So they're not the same size, but they're similar. And so the idea is that there's not enough information for some of those. So these triangle congruence theorems allow us to now, instead of prove 6 things, most of them are just 3, which makes it a lot easier. All right, y'all. See you later.